Hey guys, welcome back to my channel. In this video, we'll be doing question 1 from class 12 HSC Mathematics Part 2's Chapter 2 Application of Derivatives. So what does the question say? Check the validity of the Rolle's theorem of the following functions. So what is Rolle's theorem? Rolle's theorem or Rolle's theorem, as many of you like to call it, basically has three conditions. What? That if you have a function f of x, it should be continuous in a given domain, okay, in the closed interval of a given domain. All right, it should be differentiable in the open interval of a given domain, and that f of a should be equal to f of b, where a and b are the limits of your domains. So if f of x is said to be checked in a comma b, closed interval a comma b, so it should be continuous in closed interval a comma b, it should be differentiable in open interval a comma b, and f of a and f of b should be equal. So let's see if the given conditions are applicable to our first question. Alright, so is f of x continuous in a comma b? It's a quadratic function, right? And we all know how the graph of a quadratic function goes, right? If this is the graph, your quadratic function goes like this. So obviously it's always continuous. Okay, then if it's continuous, what's the next thing? It should be differentiable in a comma b. Is a quadratic always differentiable? Yes, a quadratic function is always differentiable. Very good. So these two are satisfied. Then is f of a equal to f of b? Let's check that. Okay. So in this case, a is 1, right? So it's a comma b. So a is 1 and b is 3. F of 1 is equal to 1 minus 4 plus 3, which is equal to 0, and f of 3 is equal to 9 minus 12 plus 3, which is again 0. So f of a is equal to f of b. Hence, Rolle's theorem is valid for first question. Let's see the second question here. F of x is equal to e to the power minus x sine x is to be checked between 0 and pi. So we all know that it is continuous. This function is always continuous. Sin x divided by e to the power x is always continuous. Alright. Is it differentiable? Yes, it is. E to the power minus x becomes minus e to the power minus x sin x plus e to the power minus x cos x. So it is differentiable all the time, even at these values. Okay. So it's satisfying the first condition. It is satisfying the second condition. Now for the third condition, if you put this and this has to be equal. So let this be a, which is 0, and let this be b, which is pi. So f of 0 is basically equal to e to the power 0, which is 1. Okay, e to the power minus 0 and e to the power 0 both are 1, and sine 0 is 0, which is equal to 0. Now let's see for pi. F of pi, e to the power minus pi into sine pi is 0. Alright, so this is 0 again. So f of a is again equal to f of b. So this is again valid. Okay, Rolle's theorem is valid for this question. Moving on, f of x is equal to 2x square minus 5x plus 3. This is again like your very first sub question. Alright. Since it's a quadratic, it is both continuous and differentiable. So the first two conditions are satisfied. Now let's see what happens for the last condition, that is f of a and f of b. F of a is f of 1, right? So f of 1 over here will be 2 into 1, which is 2, minus 5 into 1, which is 5, plus 3, which is 0. And f of 3 will be equal to 2 into 9, that is 18, minus 5 into 3, that is 15, plus 3. Okay, so as per the conditions over here, the first two conditions are easily satisfied. And when we get to the third condition, it is satisfied again, right? So let's see, 2 into 1, that is 2, minus 5 plus 3, 0. 2 into 3 square, that is 9. And then minus 5 into 3, that is 15. So 18 minus 15 is 3, plus 3 is 6, right? So this is not equal. So hence it is invalid. It's not valid, it's invalid. Moving on to the fourth sub question. F of x equals sin x minus cos x plus 3. So let's see. Sin x minus cos x, it is always continuous. Even if you add a 3, it is always continuous. So the first one is satisfied. For the second condition, is it differentiable? Yes, it is differentiable. It becomes cos x plus sin x plus 0. So it becomes cos x plus sin x. Hence it is also differentiable. Let's see if it gives the same value for these two functions. So f of 0 will be sin 0 is 0, cos 0 is 1 plus 3, that is equal to 2. And sin f of 2 pi gives you sin of 2 pi, which is 0, minus cos of 2 pi, which is 1, plus 3, which is 2, which are equal. Hence this question or this function is valid Rolle's theorem. Okay. Fifth, that is the second last question. F of x equal to x square if x is between 0 and 2, and f of x equals 6 minus x if it is between 2 and 6. So let's see. Is it always continuous? So if you check at 2, x square is 4 and x minus 2, that is 4. So yes, it is continuous. Is it always differentiable? Yes, you can differentiate it. So let's see if it is, if f of a is equal to f of b. So over here, if you put 0 in place of x square, you get a 0, and 2, you get a 4. Over here, if you put a 2, you get a 4, and a 6, you get a 0. These values are not corresponding, right? So here it becomes invalid. Here it becomes invalid. Why? Because the values are not corresponding. Coming to the last question, f of x equals x to the power 3 by 2. Okay, so now f of x is differentiable. Yes. Is it continuous? Yes. So let's see. F of minus 1 is equal to minus 1 to the power 3 by 2, which is equal to the cube of this is minus 1, and minus 1 root of minus 1 gives you I. Okay, which is root of minus 1. Now going to f of 1, 1 to the power 3 by 2 is equal to 1. These two values are not equal. So this equation is invalid for Rolle's theorem. So guys, with this we are done. Okay, so let's just recap what is the condition for Rolle's theorem. For Rolle's theorem to hold true, over an interval, okay, let's say the interval is a comma b, the function should, the f of x, the function that you have, should be continuous in the closed interval. It should be differentiable in the open interval. And lastly, value if you put in the starting of the interval should be equal to the value if you put in the ending of the interval. So how will you solve these questions? You will say, for Rolle's theorem to hold true, 3 conditions are applicable. The first condition is that the function should be continuous in the closed interval, differentiable in the open, and second condition is that it should be differentiable in the open interval. Then you prove these two to be true. Then the third condition you mention is f of a is equal to f of b, and then you show the working like I have showed over here and over here, and show that f of a is equal to or not equal to b. If f of a is equal to b, you can say that it is valid for Rolle's theorem. If it is not equal to f of b, you can say it is invalid. So that's it for the video. Don't forget to like, share and subscribe, and comment down below if you have any queries or suggestions. And also, if you have any other topics that you want me to discuss or explain, do put them in the comments down below. Thanks for watching.